lightweight Inception network for recognition and detection of rice plant diseases. Rice is staple globally and predominant dietary component in numerous regions, particularly across Asia, serve as a primary source of calories for over half of the world's population, profoundly influencing the global food security. The realization of food security hinges on rice yield meeting the essential requirements. That the persistent scourge of diverse crop diseases significantly impairs the rice production, a story all too familiar. This potential of deep learning and image processing and the computer vision, although largely untapped for the plant disease recognition, emerges as a pivotal. Embedded system pose the deployment challenges due to the size and computational constraints. This study introduced the MobileNet and Adept lightweight network tailored for the crop disease recognition and the detection, aiming to surmount the complexity of the efficient model training through the deep learning. And in this project, we introduced the MobileNet and the novel lightweight network architecture that revolutionize the crop disease recognition and detection through the profound capability of deep learning. Our focus extends to the formidable challenge entailed in deploying the deep learning model on the resource constrained embedded system, where voluminous data and computational intricacies pose the barrier. Our evolutional involves an optimized inception module integrating the depth wise and the point wise convolutionals, synergistically harnessed with the pre-trained mobile nets acting as a potent feature extractor. And notably, a dual stage transfer learning strategies enrichen the model training. This pioneering approach yielded exceptional average recognition accuracy demonstrated on both the public and localized datasets, imparting a new era of precision and effectiveness in the agricultural disease management. And these are the basic requirements that are needed to build this project. Software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. We need to import the essential packages including PyTorch and the relevant libraries, setting the stage for the seamless implementation of the disease recognition and the detection process. And the second one is exploring the dataset. Here we need to explore the dataset containing the rice plant images to comprehend its structure, characteristics, and labels, providing the insight for the subsequent processing. And the third one is image processing. Implement the image processing techniques such as resizing, normalization, and the noise reduction to enhance the quality and the uniformity of the images for the model input. And the next one is data extraction from the image. Extract the meaningful feature from the rice plant images, a critical step to capture the distinguishing pattern related to the disease and involves the technique like edge detection too. And the next one is splitting the data into the training and testing set. Divide the data set into the training and the testing subset, ensuring the model is trained on the representative sample and evaluated on the unseen data to measure its generalization performance. And the next step is building the model. Here the first model is PyTorch Inception V3. It is a deep convolutional neural network architecture known for its efficient feature extraction. It uses a combination of traditional convolutional layers and the Inception module that allow for the parallel processing of the different descriptive field sizes. In this project, PyTorch Inception V3 can excel in capturing the intricate features and within the rice plant images and aiding in accurate disease recognition and the detection. And the second one is MobileNet. It is a lightweight CNN architecture designed for efficient deployment on the mobile and embedded devices. It employs a depth-wise separable convolution to reduce the computational burden while retaining the feature representation. And this project, MobileNet can be available for the resource-constrained environment, enabling the real-time disease recognition and the detection on edge devices. The third one is MobileNet P2. It is the evolution of MobileNet architecture, incorporating the improvements such as inverted residuals and the linear bottleneck it offers the enhanced efficiency and the accuracy compared to its predecessor. In this project, MobileNet V2 can contribute to accurate disease recognition and detection, while its lightweight nature ensures the optimal utilization of the computational resources. And the next one is Expression. It is an extension of Inception architecture that exclusively focuses on exploiting the depth-wise separable convolution. It aims to capture the complex spatial relationship within the data, and the context of this project, it also excels in covering the intricate disease-related features within the rice plant images. And the next one is NASNet Mobile. It is a neural network architecture variant that focuses on optimizing the network architecture for this embedded platform. It employs the neural architecture as a technique to automatically discover the optimal network configuration. In this project, it effectively adopts its structure to the specific demands of the rice plant disease recognition and the detection, potentially leading to the improved accuracy and the efficiency. And the next one is Efficient Net Beat 0, which means it strikes a balance between the modal depth, width, and the resolution for the optimal performance. It employs the compound scaling to efficiently use the resources. And this project, Efficient Net B0, can offer a well-rounded solution, leveraging its efficient architecture to capture the relevant disease feature while maintaining the computational efficiency. And the next one is PyTorch GoogleNet. Also known as Inception V1, is an early Inception architecture characterized by its unique Inception module that performs the multiple convolutions in parallel. It excels the capturing features at the different scale, and in this project it be the instrumental in recognizing and detecting the rice plant disease by efficiently capturing the diverse pattern and the variation within the image. And the next one is user gives the input as an image. We need to establish a flask-based user interface enabling the user to input the rice plant image for the disease analysis, fostering the user interaction and the engagement. The next one is the given input is pre-processed for prediction. Process the user provided input image, applying the pre-processing steps similar to those who use it during the model training, ensuring the image is compatible with the model requirements. And the next one is trained model is used for prediction for about that image. Utilize the trained lightweight Inception network model to predict the presence of disease in the provided rice plant image, harnessing their learned feature to make the informal prediction. And the final outcome is displayed. Present the disease recognition and the detection outcome, indicating the predicted disease and its severity through an initiative front-end interface. And the execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of various files within it. The sample folder containing of the various images that will be used to perform the test of the model. And the rice leaf disease containing of the train and validation folders containing of the various images within it. And the static folder containing of the folders like JavaScript, images, CSS, uploads, assets within it. And the template folder containing of the HTML documents. It typically include of form, index, notebook, sign-in, sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that will be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cells, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the country directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issue. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Sorry. And then click on the enter button. Here it will redirect it to this page containing of the title and some information about it. And then click on the login button. Here it will redirect it to the login page containing of username and password, and we need to fill those details. And then click on the login button. Here it will redirect it to this page containing of the username on choose file and upload buttons. Click on the choose file button. Here it will redirect it to this page. Select one image and then click on open button and then click on upload button. Here it will redirect it to this result page and giving the prediction as uploaded image is a rice plant disease, type is brown spot. And by using the try again button, we redirect it to this page, and by clicking on the choose file button, we can select another image and then click on the upload button. Here it will redirect it to this image and it gives the prediction as the uploaded image is of leaf blast. In this way, we can detect the type of plant rice diseases. And in conclusion, the importance of timely and effective detection of crop disease by ensuring the food security, we propose a new lightweight network architecture called the mobile internet with the crop disease recognition and detection task. The proposed method uses the transfer learning and the pre-trained recognition and the detection task. The proposed method uses the transfer learning and the pre-trained mobile net with an optimized Inception module to extract the high dimension features of the crop disease images. The proposed approach is effective and feasible for detecting the crop disease even under the complicated background conditions.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.